Hi, welcome to Mr. Techpathy Tutorials. This is part 2 of Linux device drivers. As a prerequisite, I strongly recommend you to watch part 1 of Linux device drivers from Mr. Techpathy videos. In this part, we will learn about following topics: system memory, kernel space and user space interaction. Also, we will learn about kernel modules like static modules and dynamic modules. So, let's start with our first topic, system memory. What is system memory and how is it related to user space and kernel space? In Linux, system memory can be divided into two distinct regions, kernel space and user space. We all know that every system has certain amount of memory. This memory consists of random access memory cells whose contents can be accessed at extremely high speeds but are retained only temporarily while the system is in use or while the power supply remains on. Coming to the purpose of this system memory, it holds programs and data that are currently in use and thereby serve as a high-speed medium between central processing unit and the much slower storages like hard disk drives. Hope you understood how system memory, kernel space and user space are related. Now, let's move to our next topic, kernel space and user space. From the figure, consider the big block as system memory. The left partition is the kernel space where the operating system runs and provides services. The right partition is the user space where user process run. What is a process here? A process is an executing instance of a program. One of the roles of the kernel is to manage individual user processes within this space and to prevent them from interfering with each other. Note that the device driver runs in kernel space and not in user space. All applications run in user space but not in kernel space. Every device driver programmer should remember these points. Coming to our next topic, kernel space and user space interaction. How does this interaction happens between kernel space and user space? To answer this question in short, it happens only through system calls. What are system calls? The system calls are the requests in Linux like operating system by an active process for service provided by the kernel, such as input output or process creation. In this, what exactly we mean by active process? An active process is a process that is currently processing in the central processing unit, whereas the process is the one which is waiting for its next turn in the CPU. Pictorially, let's see how this interaction happens. From this figure, top block is the user space where users process run. They interact with the next block, that is the kernel space block, using only system calls. Please note that the user space processes can't access the hardware directly. They need to use system calls for accessing certain functionality of the hardware. These system calls are implemented by a driver and runs in the kernel space to provide functionality of hardware to the user. All these interactions are managed by the core kernel. If we go one step further and relate the previous user space and kernel space diagram with our program, kernel and hardware, it will resemble as this figure. Application program will reside in user space and driver will reside in the kernel space as shown in the figure. System calls are the only way for a user space program to access kernel space device drivers. Hope you are clear with kernel space, user space and their interaction using system calls. Okay, let's jump to our next topic, kernel modules. Kernel modules can be classified into two types, static modules and dynamic modules. What is a static module? Static modules are compiled as a part of kernel and are available at any time. These make the kernel larger and has the disadvantage of requiring us to rebuild and reboot the kernel every time when we need a certain new functionality. From below figure, You can observe that the static modules SM1 and SM2 are internal part of the kernel image. They always reside in the kernel image. Any single modifications to this module will require us to rebuild the whole kernel, which consumes time and effort. Next, what is dynamic module? Dynamic modules are pieces of code that can be loaded and unloaded into the kernel upon demand. They extend the functionality of the kernel without the need to reboot the system. After loading the kernel, we can load these modules using ins mode and unload using RM mode. We'll be discussing about ins mode and RM mode in upcoming tutorials. Dynamic modules have the advantage that it uses the memory more efficiently than the statically linked modules. From the figure displayed, DM1 and DM2 are the dynamic modules which are not part of kernel image but still can be loaded into the kernel depending on our need. So that's it for today. This is end of part 2 of Linux device drivers. I hope you are clear about the topics discussed in this part. If you are not clear on any topic discussed till now, please watch part 1 and part 2 multiple times without missing any point. This will also help you in upcoming tutorials. We'll continue our next topic in Linux device drivers part 3. Till then, stay tuned. Please feel free to comment and query. Don't forget to subscribe Mr. Techpathy videos in YouTube. Thanks for watching and goodbye for now.